Good day from wherever where you are watching from, wherever place you are watching from, and whatever time you are watching from. This is the YouTube tutorial brought to you by CCCSP FUSA Academic Unit. And today we'll be discussing, or we'll continue from where we stopped in MTS 104, and we'll be taking the third section of the work. As I said, we'll be taking this and limiting it or tailoring it to the footer, contents, and manual. So, the topic before us is the geometry of a circle. See, the geometry of a circle, that is, we have to talk about a circle and the things it entails. But before we do that, what would help us the more is talking about line first, because you get the construction of your circle from line, and there are some line parameters we make use of that would be using the circle as well. So let's start with some little revision on line, revision on straight line. So, as you know, when you have a point and a point, and you have a line, the distance between 2 points is what you call your line. Now, for the construction of a line, there is the general equation of a line, which goes as y equals to mx plus c. So, if you have your gradient xy, if you have your gradient, I think you're changing y by changing x, and your slope, your gradient is also known as the slope, and if you have your c, which is your intercept, it means you can get the equation of any line. So let's assume I have my gradient to be 2 and my c, your c means where it cuts y axis. So my c is 2, so it means my equation is y equals to 2x plus 2. Do you understand? So equation of a straight line, this is the general equation of a straight line, but your formula for your m will be y2 over y1 x2 minus x1. So if I have, let's say, a line passes through 2 points, 1, 2 and 4, 7. So if a line passes through these 2 points, how do you get the slope of that line? M equals to 7 minus 2, and let me change this to 8 minus 2, that is y2, x1, y1, x2, y2. So y2 minus y1, 8 minus 2, x2 minus x1, that is 4 minus 1, and that is 6 over 3. So your slope is 2. So if I'm to get the equation of a line that will pass through this 1 and 2, 4 and 8, it means y equals to 2x plus 2. That is y equals to mx plus c, rather. Y equals to mx plus c. So how do I get this, my point C? To get your point C, you just need to pick a point out of this two. Considering point 1, 2, you can use 0.48, anyone. So it means when y is 2, x is 1. So 2 equals to 2 plus c. 2 minus 2 equals to c. 0 equals to c. So it means your c is 0. Now you've gotten your c. Your equation is y equals to 2x plus 0, which is y equals to 2x. And to confirm you are correct, if x is 4, 2 times 4, 8, then y is 8. So this is how to get the equation of a line. Once you get your slope and your c, you are good to go. They might give you directly that your slope is this. Let me call this common figure 1, and let's call this common figure 2. So you might be given your slope and your c directly, you impute it. You might be given 2 points. You first get your slope from that 2 points. Then after getting your slope, you pick one of those points, then use it. Another type might be you are given your slope, that is your gradient, as 2 or minus 3. Then say passing through point. If the slope of a line is minus 3 and it is passing through point 7, 4, get the equation of that line. So y equals to mx plus c. Your m, you already have it. Y equals to minus 3x plus c. So you just need to make it pass through. When y is 4, x is 7, then impute it, get your c, then go back and write your equation. Another formula to get your slope is this, and to get the equation of a straight line is a combined formula, which has y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. This is your formula for your m. So this is your a very straightforward formula. Once you have 2 points, but this one is used for just 2 points. So once you have 2 points, I can just put it here and say y minus, let's go back to this equation. If I want to use this formula, y minus, where is my y1? 2 equals to m Once I calculate my m from here, but I calculated it from here, so let me use it. 2x xy x1. Where's my x1? 1. So y minus 2 equals to 2x minus 2. So y equals to 2x minus 2 plus 2. Y equals to 2x plus 0. So it's still the same answer it will give you. So either use this general formula, that is if you have 2 points, or better still just stick with this. There are 3 conditions. When I have my m and my c, I'm good to go. Just put it and I've gotten my equation. Or when I have 2 points, first get the gradient, then pick the gradient and the point. Or this one, when they give you the gradient and the point. So this is the first one. When you have gradient and your c, you've gotten the answer. When you have gradient and a point, just put your gradient, then put the point to get your c. Then the last one, when you have 2 points, get your gradient using the gradient formula, y2 minus y1 over x minus x1. So once you get it, just pick a point with that gradient that you have to get your c. And once you get your c, you write your equation out. So this is for straight line, how to get the equation of a straight line. So let me quickly put out some demonstration of slopes. When you see a line moving this way, you will know it will have a positive slope. Why? Because if this is your angle 90, this will be y2, y1, x2. At that angle 90, you used to have x2 and y1, and this is x1. So your y2 is greater than your y1, so it will give you a positive value. Your x2 is greater than your x1, it will give you a positive value. So positive divided by positive. So this one is a positive slope. Positive slope. But lines that look like this, they give a negative slope. Why? Because at this your angle 90, this is your y1, x2. Do you understand? So it means this one will be y2 and this one will be x1. So you can see that your y1 is greater than your y2. So y2 minus y1 will give a negative value. So this is the negative slope. So this is just by the way. I'm telling you that if you see a line that goes this way, it is going upward. So that is a positive slope line. Coming downward, that is a negative slope line. Are we good to go? Now let's look at the distance between two points. That is, if I have a point here and I have a point here, what will be the distance between them? If I measure it with a ruler, what will be the length of that point? So that is what we'll do now. So now for the length, I thought if you have a point here and a point here, let's say this is point 1, 2, and this is point 4, 6. So how do you know the length of this line? That's what we call length, between 2 points. So the formula for getting the length between 2 points, length of a line is square root of the x2 minus x1 square plus y2 minus y1 square. So it's just like representing it with a triangle and saying y2 minus y1, this is the change in y, that's your y2 minus y1, this is the change in x. So to get this length, that is Pythagoras theorem. That is this one square plus this one square. So that is what we just denoted it with. So x2 minus x1. So I have, what is my x2? That is 4 minus 1. Or let me change this to minus 1 and 3. Let's change it so that you can see that how you can work with negative as well. So 3 minus x1, that is minus 1. So put into bracket because it's having the sign plus y2, 6 minus y1, 2 square. That is square root 3 plus 1 square plus 6 minus 2, 4 square. 3 plus 1 is 4. So square root 4 square plus 4 square. That is 16 plus 16. That is square root of 32. By the time you find square root of 32, you should be having 5 point something. That is 4 root 2. 4 root 2, that is 4 times 1.414. And when you multiply this, you should be having 5.6, 2, 5.6, 6, 1, 4, 5. Like that. So unit. So this is how you get the distance between 2 points or the length of a line. Are we good to go? Now let's go back to the equation of a line we spoke about the other time. Don't forget, I already gave you the formula for tangent, which is y2 minus y1 of slope rather equals to x2 minus x1, and it's also tan theta. Yes, it is also tan theta. If you have a line and the description is given by an angle, if they say the angle is 20 degrees to the horizontal, you can get the gradient by just saying tan. Let's say this is 20 now. Tan 20 degree. That's your m. You are good to go. You've gotten the tangent. So that's another formula for tangent. Your theta angle between that line and the horizontal. Are we good to go? Now there are cases where they want you to get a line, but they won't give you the m or the c. that is the gradient of the intercept, they will just tell you that they will give you in relation to another line. Listen, for instance, let's assume I have an equation that goes thus: y equals to 2x plus 3. Let's assume I have this equation. Then I say find another equation that is parallel to this. That find the equation of a line that is parallel to this line I gave you, this first line I gave you. This line is parallel to it and it is passing through point 57. That is, I want you to form a line for me that would be parallel to this line and it would pass through 5,7. So I need a line, a new line that is parallel to y equals to 2x plus 3 and passes through point 5,7. So for this my new line to be parallel to this one, so let me call my new line, let the gradient of my line, my new line, let the gradient of my line be m. If two lines are parallel, two parallel lines will have same gradient. So for two parallel lines, it means the gradient of one is the same thing as the gradient of the other one. But if they are perpendicular, this is what perpendicular means. It means that the product of their gradient, that is the gradient of the first line and gradient of the second line, when you multiply together, must give you -1. Do you understand? So this is for parallel lines, they have the same gradient. For perpendicular lines, the product of their gradient is -1. So this question says you want a new line that is parallel to this line and is passing through this point. To get the equation of the line, the new line they want, I told you any equation you need for a line, you just need the gradient and the intercept. So you already have the point it is passing through. So you know that is like condition number 2. The first condition, you have m and c, are good to go. The second one, you have m and a point. The third one, you have 2 points. So this one, they're giving us a point. So the only thing we need is m. So you can get your m from the line they gave you. They said this new line is parallel to this one. And what's the condition for parallelism? It means the new line you're looking for and the former line you have, they should have the same gradient. So what is the gradient of this line? The gradient of this line is 2x plus 3. So y equals to mx plus c. Correlating it means this is your gradient. Yes or no? So it means the gradient of the old line is 2. For our own new line to be parallel to it, it means the gradient has to be 2. So I've gotten the gradient for my new line, which is 2. And it is passing through, and they said that my new line is passing through 5 and 7. So just go y equals to 2x plus c. Then imputing this point, 7 equals to 2, 5 plus c. 7 equals to 10 plus c. 7 minus 10 equals to c, minus 3 equals to c. So y equals to mx, 2x plus c. That is minus 3. So this is my new line that I'm looking for. It will be parallel to 2x plus 3. Why? Because they have the same gradient. Do you understand? Now let's assume the question says find the equation of a line, perpendicular to y equals to 3x plus 4, passing through 2 and 1. So this question is saying that find a line that is perpendicular to 3x plus 4. If this is the line of 3x plus 4, let's assume this is the line of 3x plus 4. The line perpendicular to it means the line, I will do like this. This is the line. So this is y equals to 3x plus 4. Let's assume. So it means I'm looking for the equation of this new line. I'm looking for this one. Y, let me call it y yn. That is my new line. So for the two lines to be perpendicular, it means the product of their gradient is equal to -1. So this is what I need to do. The gradient of my new line, to get it will be -1. Okay, let's go with the formula I said. I said the gradient of your new line and the gradient of your former line that you have, they must be equal to -1. So the gradient of your new line is -1 over the gradient of the line they gave you. What's the gradient of line they gave you? 3. Y equals to mx plus c. Let's assume what they gave us is not y equals to mx plus c. Let's assume it is 2y equals to 3x plus 4. I'm changing the question so that I'm increasing the level of difficulty. If you have 2y equals 3x plus 4, what is your gradient? The first thing you have to make sure you do is that you have to make sure that your y is standing alone. look at here, it is 2y equals to 3x plus 4. So to make your y stand alone, solve the formula, you have to divide all through by 2. So y equals to 3 over 2x plus 2. So it means your gradient is 3 over 2, right? So for you to get the gradient of the new line, since they are perpendicular, the gradient of your new line has to be minus 1 divided by the gradient of the line you were given. So what is the gradient of the line you were given? 3 over 2. So minus 1 divided by 3 over 2 will give you minus 2 over 3. This is your gradient of your new line. Now that you've gotten the gradient of your new line, you can get the equation of that new line. So how do you get the equation of that new line? You say y equals to mx plus c. Y equals to, what is the gradient of your new line? Minus 2 over 3 plus c. And since it is passing through 2, 1, then you impute it. 1 equals to minus 2 over 3, x is 2 plus c. So your c is 1 plus 4 over 3, and that is 7 over 3 by the time you find LCM. So your c is 7 over 3. Now let's write the equation. The equation becomes y equals to the gradient of our new line minus 2 over 3x plus our c, 7 over 3. So you can multiply all through by 3, then you have 3y equals to minus 2 over 3x times 3 plus 7 over 3 times 3. This is why we're multiplying all through by 3, is to make sure that our denominators are cancelled and we just have, so 3 cancels 3, 3 cancels 3. So 3y equals to minus 2x plus 7. So 3y plus 2x equals to 7. This one is just a way of writing it to make it, make sense and look clean. 3y, bring in minus 2x here, plus 2x equals to 7. So this is how you get the equation of a line that is parallel to another line or that is perpendicular to another line. So are we good to go? Having done the gradient of a line, the equation of a line, when you have the m and c, when you have the m and a point, when you have 2 points. Do you understand? And we've also taken out how you get the equation of a line when you are given its relation with another line. That is, if it is parallel to another line or if it is perpendicular to another line. It's simple. You just know you need to get your gradient from that equation of that line given. Then you use your points you are given to finish it on. So those are what we've done so far. Now, many times or sometimes, they don't give us just the equation of a line, and they ask us to get another line. Do you understand? They give us the equation of a curve, and they say we should get the equation of a line that is either tangent to the curve or parallel to the curve. This is what they meant by it. Let's assume you have a curve like this. So the equation of a line that is tangent to this curve. Look at this curve now. This is what you call tangent to it. It's in it partly. Do you understand? So they might say get the equation of a line, of this line, y equals to mx plus c, that is tangent to this curve at this point. They'll give you that point that is tangent to it, or normal to it. If this is tangent, this is normal. So normal to it at this point. So how do you do that? So before we go into how you do this is also simple. It's just the way you've done equation of a line that is parallel to another line, equation of a line that is perpendicular to another line. Do you understand? But before we go there, let's look at how do we get the gradient of a curve. We've only known how to get gradient of a line. For instance, if I give you 3y minus 7x plus 6 equals to 0. This is the equation of a line because you have just your y and x. There is no square on it. Okay? So this is your equation of a line. To make it look more as the way in the other, it is 3y equals to take your x to the other side. Then divide both sides by 3 so that it will be clearing. So if you look at this equation now, if you compare it to mx plus c, you can see that your m is 7 over 3, intercept on the y-axis is minus 2. So it means if you are given the equation of the line, you can quickly tell what the gradient is by just looking at, after making sure y is the subject of the formula, make sure y is the subject of the formula. You see, there is nothing in front of y. It is the subject of the formula. Just look at what is in front of your x. That is your gradient. But what if it is a curve? Let's assume you have a curve, x squared plus y squared minus 2x minus 4x plus 2y minus 8 equals to 0. Now, what is the gradient of this curve? Now, for a curve, this is a circle. You see, the gradient on this circle is different at each point. At this point, the gradient is different from what it is here. It's different from what it is here. If you draw your line now, you see that this line will be different from how this line looks. Do you understand? Different from how this line looks. So the gradient is different at this point. So when they ask you to get the gradient of a curve, they will give you the points they want you to get it. So let me say get the gradient of this curve at point 0, 2. So get the gradient at point 0, 2. So want to get the gradient of this curve at point 0, 2. So what do? You see, let's come back to this equation of a line. If I want to get the gradient of this line, this y equals to 7/3x minus 6/3. If I want to get the gradient, there's something else I can do. What do I need to do? I just need to differentiate. So let me differentiate this y. The y dx with respect to x. Differentiation of 7/3x, that will give you 7/3. Differentiation of a constant, that will give you 0. So if you have this equation y equals to 2x plus 1, what's the gradient? Just differentiate it. Differentiation of this will give you 2, and that's the gradient. So it means if you differentiate an equation, that's the gradient of that equation. Now look at this curve. Going back to this curve, we want to get the gradient of this curve. I told you for a curve, it will just give you the equation. Let's get the gradient. I told you to get the gradient, you can just differentiate, then you are good to go. So getting the gradient of this curve, it means let's differentiate. And if you are differentiating, we call this partial differentiation because you're having x and y multiples. You don't just have one y, you have a lot of y's and you have x. So to differentiate, you differentiate them. Whenever you differentiate x, it's normal. Whenever you differentiate y, you put dy dx. So let's go. Differentiation of, I cannot collect the like time because there's y squared, there's y. So which do I collect like? So I just need to differentiate all of them the way they are. So differentiation of x squared gives you 2x plus differentiation of y squared gives you 2y. Then you put the y dx. Do not forget I told you to do that. Differentiation of 4x gives you, minus 4x gives you minus 4. Differentiation of 2y gives you 2. Then you have to put the y dx to show that I differentiated y there. Differentiation of minus 8 equals to 0. Then this is 0. So now, collecting like terms, 2y dy dx plus 2 dy dx equals to 4 minus 2x, right? Then 2y plus 2, when I factorize and bring out the y dx, equals to 4 minus 2x. So dividing both sides by this, so that the y dx remains 2y plus 2. So dy dx equals to 4 minus, so this is the equation for the gradient. So this is the gradient equation for this curve. That's why I told you that, you see, if your x is a value and your y is a value, the answer you get to be different if that x is another value and your y is another value. That's why the equation of a curve, the gradient of a curve is different at different position. Do you understand? So for this one, they said at x equals to 0 and y equals to 2. At x equals to 0 and y equals to 2. So let's come here to put our, our x equals to 0. So 4 minus x equals to 0, y equals to 2. So gradient equals to 4/6. That is 2/3. So it means the gradient of this curve at that point is 2/3. Now listen, if you ask you to get the equation of a line, so let me say this is the curve now. So this is the point, let's say this is the point 0, 2. Now, if they say find the equation of a line that is tangential to this is it. Line tangential, y equals to mx plus c. And if they say find the equation of a line that is normal to it, this will be normal to it. Another y equals to mx plus c. So how do you do that? So I told you it's still the same way, parallel and perpendicular is. Now look at it. Let me write a code here. Let me write a simple way here on the board for you to know how it works. So don't forget, while we were treating line to line, I'll call it line to curve. That is line, curve. So if it was, parallel, for line to line, if it was parallel, we say m1 equals to m2, right? That's the same thing that happens if they say it is tangential. So instead of using the word parallel for curve, they cannot say find the equation of a line that is parallel to this curve. No, that is tangential to that curve at that point. Because this line is tangential. If you look at this line and this curve, they are tangential here. But this line is not tangential to a point here, to the curve at the point here. No. So for every point, there is a line that will not be tangential to it. So we say, what I'm saying is, if line is parallel to another line, it means the gradient of the two lines are the same thing. But here, if line is tangential to a curve at a point, the gradient at that point is equal to the gradient of that line. Do you understand? So here, if it is perpendicular, if two lines are perpendicular, it's the same way you would treat if a line is normal to a curve. And that way you say the gradient of one is -1 divided by the gradient of the other, or the product of the two gradients is equal to -1. Do you understand? So when you hear the keyword a line is tangential to a curve, it means the gradient at that point on that curve and that line will be the same thing. If it is normal, the gradient yes, at that point, at the point in that curve is, times the gradient of that line give you -1. So I'm just saying, treat it the way you do for perpendicular line, treat tangent the way you do for two parallel lines. So now let's solve this question in both cases. Now let's assume that same equation, the x square I gave you, is tangential. So the question says find the equation of a line that is tangential to x square plus y square minus 4x plus 2y minus 8 equals to 0. So find the equation of a line that is tangential to this curve at 0, 2. So the first thing is, I've gotten the gradient of the curve. The gradient of the curve is, how I got the gradient of the curve this way. So I got the gradient of the curve at that point. So if the line is tangential, if the line is tangential to the curve, it means the gradient of that line, if it is tangential, line to curve, it is tangential, it means the gradient of that line is equal to the gradient of that curve at that point. So the gradient of the line I'm looking for is gradient of the curve. And what's the curve? 2/3. Do you understand? So I now write y equals to mx plus c, that's the equation of a line. And now I've gotten my gradient of that line, which is the gradient of that curve at that point. Because line that is tangential to a curve means that line has the same gradient as that curve at that point. So y equals to 2/3x plus c. So what do I need to do? I have my gradient and I have a point it is passing through. It is tangential to it at this point, and it means it is passing through that point too. Tangential means it is touching it. So if it is touching it at that point, it means it is passing through that point too. So I can see is that point, and this is condition number 2 for getting condition number 2 here is for getting equation of a line. We said condition number 1 you are given m, you are given c. Condition number 2 you are given m and a point. Condition number 3 you are given 2 points. So this is condition number 2 when you have a gradient and a line and a point. So just put when x is 0, y equals to 2, y is 2, x equals to 0 plus c. So all this gives you 0, c equals to 2. So the equation of the line is 2/3x plus 2. So you can multiply all through by 3 and have 3y equals to 2x plus 6. That's still good to go. Now what if the question had said find equation of a line normal to it? Now let's do equation of a line. This one is tangential to it. So equation of a line normal to the curve. So equation of a line normal to the curve, line normal to the curve. So if a line is normal to the curve, it means the product of their gradients should be -1. You treat it the way it will be done for perpendicular to a line. It had been a line, not a curve. So I will say normal to the curve. It means the gradient of my line is -1 divided by the gradient of my curve at that point. So what is the gradient of your curve at that point? -1 over 2/3. That's the gradient of our line at that curve. You understand? So the gradient of my line, would be -3/2. So what will be the? So it means this time around, this is not my line. This is my line. Since it is normal to it. So this is it. It means the gradient of that line, gradient of that curve, their product will give us -1. That is, their product will give you -1, and that line will still be passing through 0, 2. Because it is normal to it at that point, so it means it is passing through it too. So y equals to mx plus c. I have my gradient now, that is -3/2. Now it is passing through 0, 2. So it means y is 2 when x is 0. So y equals to, this will give me 0. So c equals to 2. So the equation would have been -3/2x plus 2. So I can multiply all through by 2. So in your test, the answer might be this way. Still the same thing with this. I just rearrange. So thank you.